So you probably have a curved monitor that kind of goes 360 around you, also, at least.
Yeah.
Very good for editing, for example, if your timeline spans like, I don't know, 2 hours or so.
Never ends, actually. It just goes in a circle around you.
Right. But the newest thing is that not only the monitor is curved, but the image sensor is curved. But probably not for the same reasons as the monitor.
No, probably not. But actually, maybe.
Maybe. Well, the first question is, why would you want a curved sensor?
Yeah.
It's a weird idea when you...
It seems very counterintuitive to do this, and in the beginning it hurts your brain a little if you start to think about it.
Yes. But then we actually read up about it a bit, because we're interested. And it turns out that a lot of the glass elements inside a lens design, because every lens has like 5, 9, 13, 20, or I don't know how many elements that actually turn the light into the shape and path it should be. A lot of these elements are created just to compensate for the sensor being flat. Because if you think, all the lens shapes are all curved. So light coming from the corners of the image have to go a different route or a different distance to the sensor surface than the light from the lens center. So what if the sensor curve takes care of that already? And it turns out you can create much higher quality glass or less complex glass with less lens elements.
The glass isn't higher quality. The glass is always high quality, I suppose, but you have less of it.
Less glass means the light has to pass through less layers of imperfection, so to say. Because every glass element always suffers from some small, even if it's small imperfections, because you can't manufacture 100% perfect glass. So the more glass you have in front of your sensor, the more it degrades the image. So less glass elements means that less degradation is happening, and if you need less glass to compensate for effects that you don't want, you also end up with a better image in the end.
Theoretically.
Yes.
But actually, it makes sense.
Yes. And so the guys from the laboratory in Marseille, the Laboratory Astrophysique, I hope I'm pronouncing that right, probably in Marseille, developed a curved sensor prototype and used the AXIOM Beta for evaluating, measuring and testing that sensor, because the sensor is based on the same image sensor we use, the CMV 12000, and the curvation on top of that silicon layer is basically their innovation, and that's the cool thing.
It looks very cool.
It's definitely.
I hope they really, I don't know, it's actually a really cool project. I hope they can get momentum with this, and so that some lens production company, they can try maybe out a few new lenses with less glass elements.
Yeah, definitely. It will take less space, I guess, for the lens, or more compact lenses might be possible.
It will be lighter, cheaper.
Yes, and still the same or even better quality in the end in terms of projection. So definitely a way into the future. We'll see how long it will take until we provide a curved sensor in the AXIOM. But in the end...
we can do it right now.
Actually, yes. Tomorrow, basically. Great. So the way we envision to record raw footage with the AXIOM Beta, because currently we're still limited to HDMI, is through a USB 3 plug-in module. So you would connect a small PC, small computer, laptop, or a very compact NUC to receive the data stream from the camera and store it, process it on that small PC, basically. The big advantage of this is that in contrast to any HDMI, SDI signal, we are not limited to certain standards, like 25 frames per second, 30 frames per second. And standard is also in terms of resolution. You can't do anything that's not full HD, not 4K, not UHD. The bit depth is predefined, and in terms of metadata, you have to fit everything within certain kind of framework.
Also, data just gets lost
Yes,
on the way.
It does no defined way of transferring RAW, for example. I mean, every car manufacturer does his own approach, but there is no standard. So the big advantage of USB 3 is we can transfer any data at any resolution, in any frame rate, at any bit depth into the container we define, and store any metadata like motion, tracking information, camera motion as well in the same container. We control the entire processing pipeline from acquisition to actually storing the data. So that's why USB 3 is so significant. The question is now, how do we store, or what is the technology to store this data?
Yeah.
And
it's not just a video you can watch in the end.
Exactly, it's raw, it's uncompressed, it's not debired yet.
It's real raw, not
pure raw.
The raw you get from other cameras, where it's just a flat image with more data.
But the beauty of that solution is that you can use pretty much any off-the-shelf PC, as long as it can sustain the data rate and can write the data to some storage media. And there are solutions on the market which are pretty compact, lightweight, very energy efficient, which is the NUC platform basically. And recently a team from AXIOM Spain met with a company called Slimbook, and they are also developing their own kind of flavor of very compact NUC alternative solutions in that very similar form factor, very Linux-centric, so that's great. And we are currently evaluating the possibility to create an AXIOM Recorder as a kind of special device into a kind of film magazine form factor. We have the PC and a storage medium, which is currently envisioned to be a 2.5-inch SSD, into something that you can attach, integrate, or put into the rig of the AXIOM Beta and directly use it as recorder for the raw footage from the AXIOM Beta. And there are many more possibilities. We covered this in the last team talk already, but I can't get tired of explaining it over and over. If you have a small PC in hand already that kind of takes care of capturing the footage, you can do many other things as well once you acquire that footage. You can transcode it to preview streams, to dailies. You can do initial raw processing, color grading. You can use it as a playback device. You can even upload the footage to some platform where you transfer the footage for online editing. You can create live backups by streaming the footage to your remote server location where the footage gets stored. So many possibilities. That's the beauty. And it's all basically off-the-shelf hardware. So there's nothing special to be developed.
But you could do that with any camera actually.
Well,
if you just capture it with HDMI. I mean, you have all
then
these...
you are limited to HDMI again.
Sure, you have all these limitations, but actually you could do it right now too, already.
We could do it from an SDI or HDMI source, but you lose all the advantages of the raw aspect, of the metadata you store, and so on. So yeah, let's see how that develops and if the AXIOM Recorder will feature the Slimbook hardware soon. Currently,
I'm really curious about the film cartridge thing. That's really nice.
So as you probably see, there is holes at the bottom, there are holes at the bottom, and there are holes at the top.
You're not speaking about the mount holes.
No, I'm talking about the air holes and the heat dissipation concept. And the big challenge we were facing, and we talked to a lot of people, and it was quite a challenge to find, or actually we didn't find people who are experienced with air filter solutions for electronic devices like this.
Yeah.
The challenge is, on the one side, you want to keep moisture and dust out of the camera, but on the other hand, you want the clean air and the movement and the flow of air through the camera.
Possibly as unobstructed as possible.
Exactly. But how do you keep dust and moisture out? They have to be caught somewhere, basically. You can't just say, stay outside. You have to filter them. So there's a filter at the bottom, currently envisioned to be in 2 stages. A rather rough filter to filter out the large particles, and then a finer, smoother filter to filter out the smaller particles, anything that's left from the first filter stage. But every filter, of course, adds obstruction to the airflow. So the more filter you have, the less particles you get, so the less air
resistance
flow.
Will always get more.
Exactly, the air resistance increases. And that hurts the ventilation again and the cooling that you actually want in the electronics.
Yeah.
And the next problem is that if you have filter, like in top of your oven probably, it collects the particles and the dust and everything you don't want over time, and you actually have to replace them. Mm-hmm. But how many cameras do you know where you sometimes have to replace the air filters? So I don't know how they are doing it, but our approach is that we want a particular amount of particles to stay outside, but it's not meant to be like a super airtight or not airtight super filter for any particles. Like we want only super clean air inside the camera, because then everything will collect in the filters and we'll constantly have to replace them.
Sure.
And as the heat rises exiting from the camera at the top again, if it exits the camera again, it's again no big deal. So yeah, that's the balance kind of trying to figure out and to test the different filters and actually see how they affect the airflow and the air pressure and so on. We built a kind of a wind tunnel. It's a 3D printed structure where I have a filter slot on the one hand, on the one side, and a fan on the other side. And in between you have a kind of fake processing CPU or whatever it is. It's just a kind of heat element. And that heats up the air as it passes from one side to the other. And then there are several pressure sensors and temperature sensors from outside to the inside of the heat element, and then where the air exits the whole test structure again. And that way we want to test different filters, thicker filters, finer filters, thinner structure, particle sizes, and see how that affects the airflow and if there's any air still passing actually, or what the effects are and what we want in the end in the camera.
Makes sense, yeah.
Yes.
So if you are a filter specialist,
yes,
maybe you can help us out.
Exactly.
We have to kind of reinvent the wheel again.
It's weird, but it is like this. Yeah.
Yeah.
So filter us, help us. We have new hardware, and that is the SATA development board. It hosts 4 SATA connectors and plugs into 2 plug-in module slots. It's based on the SDI development board, which also has a kind of attachment FPGA off-the-shelf board on top. And the carrier board, as you normally call boards, which have an FPGA board on top, provides the interfaces previously for SDI and now for SATA.
Okay.
So the idea is to, in the end, connect a storage device like SSDs or whatever provides a SATA interface. Yeah. So you can directly connect it to the camera and record footage, raw footage, uncompressed footage directly to storage media.
Done.
Right.
Okay,
Exits.
Let's do the exit strategy.